says, part A, if angle T is congruent to angle V and angle V is congruent to angle R, then angle T is congruent to angle R. So you may want to pause the video. You may want to look back at your properties that we glued in. We had those 3 properties today. We had the reflexive property, the symmetric property, and the transitive. Which does this look like? Hopefully you said transitive. That would be correct. All right, and part B says if line segment JL is congruent to YZ, then YZ is congruent to JL. So if you notice, all they did is flip the order. So look at your sheet. Which property says you can flip the order? That would be the symmetric property, because right now we're using the geometric properties, so you shouldn't have commutative property. That's for algebra, and this is talking about line segments. Whoops, I started writing it because I was saying it. Okay, symmetric property. And that's it for example 3. All right, question example 4. Write a 2-column proof for the symmetric property of segment congruence. So I'm going to go ahead and set up my 2-column T-chart. I'm going to go ahead and put statements on the left, reasons on the right, and let's look at this. It says given LM is congruent to NP, and it shows you that as well. It has 1 tick and 1 tick. That means they're congruent. My goal is to prove that NP is congruent to LM. So see if you can come up with the first line. Pause this if you need to. Hopefully you came up with LM is congruent to NP. Remember, you're always starting with what was given to you in the problem. So if you look up here, I'll put it in yellow, given. That should always be your first line. The proof part should always be the last. Okay, then line 2. This might feel kind of redundant, but I'm going to say LM equals, line segment LM equals. So the difference is I'm not saying congruent, I'm saying equals. All right, and my reason is going to be the definition. I'm going to abbreviate a little bit. Definition of congruent, I'm going to use the symbol, segments. All right, then for line 3, I'm going to say that NP is congruent to line segment LM. So I'm flipping the order. What allows me to do that? The symmetric property. And then I'm ending, I'm going to say that they are equal. All right, so I'm going to erase this, that they are equal. The symmetric property allows me to change the order. So if in line 2, I knew that LM equals NP, I can use the symmetric property to flip the order. And then my last line, remember you're always ending, I'm going to circle in red with what they're asking you to prove. I'm going to end with NP is congruent to LM. Maybe you can guess the reason here, but it's going to be definition, just like line 2. Definition of congruent segments. Done. All right, so here we go with example 5. And I think this is the last proof, and then we get to the summary. So that's exciting, but it's a fun one. Okay, so we'll set up our 2-column proof. Statements on the left, reasons on the right. Statements, reasons. And then let's read the problem. That's usually good to do. Okay, prove this property of midpoints. If you know that M is the midpoint of AB, prove that AB would be the whole segment, is 2 times AM, and AM is 1/2 of AB. So, sounds like a lot, but we can do this. So we're going to start with what was given to us. So set up your first line. Given M is the midpoint of AB. So that should be your first line. I'm going to have to write small here. M is the midpoint of AB. and that was given. I'm sorry, this looks so sloppy. All right, then next, let's think about, all I've said so far is that M is the midpoint. What does that allow me to say? Well, if M is the midpoint, I can say, I'm going to mark it on my picture, that AM and MB are congruent. So that's going to be line 2. AM, line segment AM, is congruent to line segment MB. What's my reason going to be? Definition of midpoint. All right, then kind of like the last proof, I'm now going to say AM equals MB. And that's the definition of congruent segments. Okay. Now, let's think about line 4, a little bit tricky. Remember, our goal here is to prove that AB equals 2AM. So let's start with AB. So here's A, here's B. What do we know about line segment AB? I can see that line segment AB equals AM plus MB. Doesn't that make sense? The big line segment equals the little parts added up. What's my reason? I'm going to say segment addition postulate. Postulate. Okay. Then my goal here is to say that AB equals 2AM. So I'm focusing on the AM here, 2AM. So I'm going to say that AB, line segment AB, equals AM plus AM. So what I did here is I changed MB to AM. Since M is the midpoint, AM, and we already proved it up here in line 3, AM and MB are equal. So I already proved that. So this would be substitution. I'm substituting AM for MB. Substitution. Then I can just combine my like terms. I can say AB is equal to 2AM. So I combined these like terms right here. 1AM and 1AM, 2AM. So that's going to be combine like terms. All right, we are almost done. Then line 7. So my other thing that it's asking me to prove is that AM equals 1/2 AB. AM. So here's AM. How can I solve for AM? I have 2AM. If I just want AM, I can divide out this 2. Divided 2, divided 2, which gives me 1/2 AB is equal to AM. All right, and that we use division, so that's our division property of equality. Division property of equality. Okay. Last but definitely not least, is our summary. Okay, so we have what is a proof. So kind of basically I'm just asking for that question, what is the 2-column proof? Why is it useful? So it's just kind of a way to make a nice logical argument. Then the second question is, what is a theorem? So how is a theorem different from a postulate? And then just kind of describe how you set up your 2-column proof with a statement and reasons. Then you should work on homework 2.5 on big ideas. Thank you.